All right, guys, today we are going to take a look at the last section in this chapter. All right, so we are going to be looking at section 2.8. So please make sure that you have your notebooks out and you go ahead and title this last section what are known as literal equations and dimensional analysis. Okay, now a literal equation and dimensional analysis. So today, here's the kind of things we're looking at. Literal equations, we're going to find out here momentarily that actually just means any equation where there's more than one variable. And what we're going to do today in these first two examples, in examples 1 and 2, is we're just going to practice solving for a specific variable. This is useful when you're given information that doesn't necessarily match up with the way the equation is presented or what the way the formula maybe is presented. And then in the last two examples, we're going to get into the idea of using dimensional analysis. All right. Now, before we get into that, we're going to take a look here at 3 questions from yesterday. So here's what I'd like you to do. Go ahead and pause your video at this point, and you're going to go ahead and try to answer these 3. When you're done, all right, go ahead and let your video play, and then you can check your work. Now, obviously, you're the only one that's going to know if you're actually doing that or not. So at this point, go ahead and pause your video. All right, so if we're checking out question number 1 here, remember, if you want to find the percentage of change, you need to take the amount of change. So that's going to end up being 96 minus 84, and you are going to divide that by the original amount. And in this case, the original amount is told to us, so we don't really need to look at which one happened first. We know that it's going to be 84. So we end up with 96 minus 84. We get a value of 12 over 84. And if we want to find the percent of change, we're going to take that answer and multiply it by 100. So 12 divided by 84 times 100 gives me an answer of 14.2857. But the directions say to the nearest whole, so we're going to call that 14%. And because it went from 84 to 96, we're going to recognize that as a percentage of increase. All right. Question number 2. So you've got, what is the discounted price of a tent that was originally $89 and now is 15% of discount, or meaning 15% off? So if we want to find that, we showed 2 ways yesterday. I'm going to turn 15% into a decimal, so 0.15 multiplied by $89 gives me, go ahead and do that there, gives me $13.35. That is the amount of discount. It is not the discounted price. In order to find that discounted price, I'm going to have to subtract. So $89 minus 13.35 will give me a discounted price of $75.65. Are you 1 for 1 and now 2 for 2? We'll find out. And in the last question, it says, what is the final price of a pair of hiking boots that were originally $78 with a 10% discount and sales tax of 6%? It is really important in this problem that you understand that the discounted price of, or the discounted amount of 10% and the tax of 6% cannot be applied at the same time. So if you did that, if you tried to say, well, take 10% off and then add 6%, and that's a difference of 4%, you can't do that. The discount has to happen first of the original 78, and then we can figure out the tax. So we'll do the discount in blue and the tax in red. Hopefully we can keep those 2 things straight. All right. So 10% of $78 is going to be 7.8 or $7.80. If I take the 78 minus $7.80, I get $70.20. That is my pre-tax total. Now I need to take that amount and multiply it by 6% to find out how much tax I owe. Remember, we are talking money, so round your answer to the nearest hundredth. I get $4.21. So $4.21 plus the $70.20 gives me a final total of $74.41. All right, so the three answers we have here, hopefully you can check those against yours. 14% increase. The discounted price of the tent becomes $75.65. No tax on that one, not according to the question. And then number three, we get a final total of $74.41. Okay, if you have questions about any of those three things, please let me know. All right, today we have two goals. Goal number one, can we solve an equation for a given variable? So like I said, if our equation or our formula is maybe solved for the total, but we already know the total and we don't know the side length, then maybe we need to switch our equation around. And then secondly, we're going to use those to help us in real world situations. So words we could come across today, a literal equation. Okay, so there's a definition for you. Anything that involves more than one variable. And I said, think about a formula. All formulas are going to have multiple variables inside of them. And then lastly, dimensional and unit analysis. And unit analysis could be thought of as a unit conversion. So maybe instead of miles per hour, you can see there it says, hey, what about feet per second? Okay, so we'll talk about making that conversion. This one here we use in science all the time. So I'm sure you guys have seen it. All right. So here's kind of an example, and then I'll have you try one after this. But we are asked to solve this equation for the variable of b, meaning get this b right here by itself. Move everything else away. So if you take a look at that for a second, stop and think, what should you move first? And hopefully you're thinking, move this 12c to the other side. Now, the 12c and the 9 aren't like terms, but we still can move it to the other side. So if I cancel those out, I'm obviously left with 5b is equal to, in this case, negative 12c plus 9. Or if you wanted to, you could say 9 minus 12c. Lastly, I don't want 5b, I just want b, so go ahead and divide both sides by 5. The 5's cancel or reduce to a value of 1, and we're left with b is equal to, now you got a couple choices here. You can leave this as your answer right there, or we can think about them individually, meaning let's do negative 12 divided by 5, and then secondly, let's do 9 divided by 5. Now, hopefully you're thinking to yourself, listen, neither one of those are divisible fractions, and you're right, and so we can leave them as we see them. Negative 12 fifths times c plus 9 fifths. And so b is equal to that. All right, so all we're really doing at this point is just practicing our solving equation skills, and it becomes a little more difficult because we don't have like terms to combine together. And so we have to keep everything separate, and we really got to pay attention. All right, so let's take a look at this one here. Okay, I would like you at this point to go ahead and pause your video and try to solve what you see. Now there's 4 choices down below, so please understand that one of these choices is your correct answer. Okay, so pause it now. When you think you have an answer, come back and let's see if you have it. All right, so now we're ready to check. Okay, just like the last time, here it says solve for the variable of y. So there I see the variable of y. So I know that's what I'm going to try to get by itself. Following the lead from our last problem, we should know that we're going to move any terms that are not attached to the variable out of there first. So in this case, we're moving the negative 2x. The 2x cancel with a negative 2x, and we're left with negative 17y is equal to negative 2x plus 13. All right, the only thing left to do here would be to get rid of the negative 17 and divide the other side by negative 17, We get the reduction there of the negative 17s. So we get y is equal to, now I'm going to be a little crafty here and I'm going to look at my answers down below and think, how do I want that to look in relation to what I see in my choices? That may help me to figure something out. So the first thing I notice is they did not separate these two fractions and these two fractions like they did the last time. So I'm not going to separate them because I don't see that in the choices down below. Now, the other thing I notice is all of my choices have a 17. Well, not the last one, not D. So I don't think D is going to be my right answer. So I'm going to cross this one out right now. But as I look at A, B, and C, I see every one of those with a positive 17. But yet I have a negative 17 in my problem. So how am I going to make that switch take place? Well, I'm going to remove those negatives anytime I see a double negative. So for example, -2 and -17, I know that could turn positive. But remember, I also have to look at the 13 and the 17. And so in that situation, what we're really going to see happen is the 2x is going to become positive, the 13 is going to become negative, and the 17 is going to become positive. Essentially, notice every value switched its positive to negative relationship. And when I do that, I can see that B ends up being the correct choice. Okay, so if you didn't get that, maybe take a second, run it back, try that again. Okay, as we move on here, now maybe we use this equation to kind of help us out. So over off on the right here, you see we have an equation. E is equal to m divided by g. E simply stands for the economy of the car. It's miles per gallon that it represents. So our problem here says if Shantae's car has an average fuel consumption of 30 miles per gallon and she used 9.5 gallons, how far did she drive? How far did she drive? Meaning, let's solve this equation for M. If I want to solve for M, I need to get G out of there. So why don't I multiply both sides of this equation by G? On the right-hand side, the G's will cancel, leaving me with something that says M, which is what I want, is equal to E times G. At that point, I know that the miles per gallon, or the economy of the car, will be 30. The number of gallons that she used will be 9.5, and I can find the total miles driven by simply taking 30 multiplied by 9.5. And if I find my calculator, 30 times 9.5 gives me a final answer of 285 miles. So averaging 30 miles per gallon, 30 miles per gallon and using 9.5 gallons, Shantae would be able to drive 285 miles. Here's the same equation with a different problem. So here, I'm going to ask that you pause your video again, give this one a shot, and see what you come up with. All right, let's check it. How did you do? This question says, if Shantae drove 1,477 miles, so 1,477 miles, and she's got an average fuel consumption of 19 miles per gallon, okay, about how many gallons did she use? So I'm trying to get G by itself. Now, here's a nice little trick that we learned about proportions. Remember, cross products in proportions are equal to each other. So if I slide over here for a second, E over 1 has to be the same as M over G. And remember, these diagonals have to equal each other, which means you're allowed to switch the position of anything that's highlighted as long as it stays in the same color. This will be very beneficial if I switch the G variable and the E variable. That'll leave me with a new equation. G over 1 is equal to M over E. And if you look over here, I know what M or E is equal to. I know what M is equal to. And it says if I want to find the gallons, just simply take the miles and divide it by the gallons or miles per gallon, the economy. So If I take 1477 divided by 19, I get an answer of 77.7368, and so on. And so I know that C will be my final answer. There is a use of manipulating an equation, or a literal equation, one with more than one variable, and solving it for what I need, not for what it gives me. So G was what I wanted. Remember, I can switch anything that's in the same color line. So I could switch the M and the 1 if I wanted to, or I can switch the E and the G. That will still produce an equivalent proportion, and I can solve. All right. Last thing we're going to do is what is known as unit analysis. So if you take a second here, the average weight of a chimpanzee in a zoo is 52 kilograms. That is kind of hard for me to think about because in the United States, we don't use the metric system. It's hard for me to comprehend how much 52 kilograms is. Is that me? Is that you? I don't know. If we can turn it into pounds, which is what they're ultimately going to ask us, how much does it weigh in pounds? We'd have a much better idea of how we relate to a chimpanzee in terms of weight. So that's what we're going to try. I'm going to do one here for you here, and then I'm going to ask you to do one after it. So follow this path. If you have questions, obviously you can play it again, or you can ask me for help. All right, so if we read this here, it says the average weight of a chimpanzee in a zoo is 52 kilograms. If 1 gram is the same as 0.0353 ounces, we're going to use the dimensional analysis to find the average weight in pounds. This conversion right here is how we're going to get out of the metric system and into the US, or what we know as the customary system. All right. So 52 kilograms. 52 kilograms. I need to get from kilograms to grams so that I can go from grams to ounces, and I can go from ounces to pounds. So that's kind of my path. Here's number 1 to 2, from 2 to 3, and from 3 to 4. All I have to do at this point is figure out how many grams, are in a kilogram. And if you know from science, there are 1,000 grams in a kilogram. Now, I'm going to write that in this location here as follows. 1,000 grams is the same as 1 kilogram. Now, the reason I put the grams on top and I put the kilograms on the bottom is because if I have the same unit on both the top and the bottom, I can cancel them out. When I multiply those two things together, 52 times 1,000, I end up with 52,000 grams. So at this point, I know that the chimpanzee weighs 52,000 grams. All right, so I've made it from kilograms to grams. Now I'm going to use this conversion right here that's highlighted to get from the metric system into the US system. So I'll make another proportion and I'll multiply that by this statement here. Again, following the idea that I would like to remove the gram label and replace it with the ounces. So that means 1 gram on the bottom and 0.0353 ounces on the top. That will allow the grams to cancel, giving me a new answer of 1,835.6 ounces. So now I've gone from grams to ounces. The only thing left to do is to go from ounces to pounds. And I was nice enough to tell you that 1 pound is the same as 16 ounces. So for my last conversion, I'm going to take 1,835.6 ounces. Again, I'm going to make a conversion there, and I am going to turn ounces into pounds. So 16 ounces is the same as 1 pound. Here, my ounces cancel with ounces, and you can see that I'll need to do 1,835.6 divided by 16, because it's in the denominator. And that will be 114.7 pounds. I don't know about you, but I'm a little more than the average chimpanzee. But now that it's in pounds, I can see that result. All right, so we have converted using dimensional analysis to get from kilograms, eventually, all the way to pounds. All right, last one, and we're done. So we'll take a second here. It says Janet is walking 20 laps of a track in a relay to raise money for cancer research. Each lap is 350 meters. The question is, how many miles will she walk? Now here, there's two conversions for us, from meters to yards, and then from yards to miles. Okay, so we can see here, we're going to have to get out of the meters into yards, and then from yards into miles. So at this point, I'm going to ask you, pause your video. You go ahead and give this one a shot, and when you turn it back on, let's see how you did. All right, time to check it. Got a couple answers down here. Okay, so go ahead and see which one of your answers matches that one. Maybe we move these up just a little bit. Move that up just a little bit so we can see it a little better. All right, so as I'm looking at this, I see this statement here that each lap is 350 meters, but I know that she did 20 laps around the track. So my first thought is, well, if she did 350 meters 20 times, then how many meters did she walk altogether? And that result is 7,000 meters. Now, just like in the last problem, I'm ready to use some of these conversions. So I'm going to start with this conversion right here because I'm currently in meters and I'd like to get to yards. So 7,000 meters multiplied. Remember, if you want to remove the meter, numerator and denominator, so you can cancel that, is the same as 1.094 yards. Okay, so let's get an answer to that. If we multiply those together, we find out that is 7,658 yards that she walked. So now our last conversion is going to be, well, there's 1,760 yards in every mile. So if I take my total amount of yards and I say, okay, 1,760 yards is the same as 1 mile. And remember, I put the yards in both the numerator and the denominator so that I can cancel them out. You can see here that you have 7,658 in your numerator multiplied by 1, so just 7,658. And in the bottom, you have 1 times 1,760. So we're doing 7,658 divided by 1,760, and that comes out to be about 4.35 miles. Okay. So that is going to be choice A down here. All right. The time you have remaining, we're going to go ahead and take a look at just a couple questions on page 129 in your book. Might be a good idea at this point to go ahead and open 2 tabs so you can keep the video there if you need it, and then you can reference it to any of these problems. Let me know if you guys have any questions.